Alright, today we are looking at Chapter 4, Topic 11. So this is multiplying complex numbers. Multiplying complex numbers. And so what's multiplying and dividing. I think we're looking at dividing. And complex conjugates. Alright, this is a new idea here, complex conjugates. So we're going to look at how do you multiply and divide complex numbers and what are complex conjugates. Alright, let's take a look at that. Let's first start by multiplying some complex numbers. So we have 5i times 3i times negative 2i. So 5 times 3 times negative 2. So 5 times 3 is 15 times negative 2. So that's negative 30. And then I times I times I, that's I cubed. Alright, well, we saw the cycles of I. So I cubed is negative I. I think we saw that. Yes, the day before. Sorry, I just had to double check there that I had my cycles of I correct. And I did. Because let me write them over here. So I is just I, of course. I squared is negative 1. I cubed is negative I. And then I to the 4th starts the cycle over and it becomes 1. And then the next one would be I again. So this, no, sorry, it doesn't. It ends the cycle. It becomes 1. And then going back to I would start the cycle over again. So I cubed is negative I. So that negative, it's already negative. It becomes 30I. Let's look at this one. Okay, so number 2, we have to use the distributive property. So let's distribute the 5. Oops, I did that kind of backwards. 5 times 4 is 20, minus 5 times 7 is negative 35i. Alright, and then we're going to multiply the 2i to each of these. 2i times 4 is 8i. And then 2i times negative 7i, so that's negative 14i squared. Alright, and I squared is just negative 1. So let's rewrite that. So we got 20 minus 35i plus 8i plus 14, because I squared is just negative 1. Alright, well, we saw how to add and subtract complex numbers. We just have to combine the imaginary and real parts. So the 20 and the 14 is the real part, so that becomes 34. And then the imaginary part, negative 35 and 8, so that becomes negative 27i. So 2 multiplies to give us 34 minus 27i. Alright, let's do the same thing for number 3. We've got to distribute 8 times negative 7, so we got negative 56. 8 times negative 2i, so we've got negative 16i. And let's distribute the negative 3i. Negative 3i times negative 7, positive 21i. Negative 3i times negative 2i is positive 6i squared. Which, remember, I squared is negative 1. So negative 56 minus 16i plus 21i minus 6, because I squared is just negative 1. Combine the real parts and the imaginary parts, so negative 56 and negative 6 give me negative 62. And then the imaginary parts, negative 16i, positive 21i, is positive 5i. So number 3 multiplies to give us negative 62 plus 5i. Now, the next one, number 4, this is called a complex conjugate. The reason that it's called a complex conjugate, or these two are called complex conjugates of each other. They're complex conjugates of each other because when you multiply complex conjugates together, you get a real number. So if you see what happens when it kind of looks like the difference of two squares, where this plus this and then this minus this. And it's very similar. And the same thing happens with the difference of two squares, is that the middle part disappears. It cancels itself out. And that's actually why these are going to end up being a real number, because the imaginary part is going to go away. So this is a complex conjugate, because when we multiply these, we will have a real number. So 3 times, So let's see that that actually happens. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3i is positive 6i. And 2i times negative 2i is negative 4i squared. And remember, I squared is just negative 1. And these two are canceling each other out. So this becomes 9 plus 4, which is 13. This is a real number. It's not complex. There is no imaginary part here. It's just the real part. It doesn't have an imaginary part. Which means that even though this was imaginary and this one was imaginary, their product is a real number. This makes them complex conjugates. And we actually have, if we have a way to create complex conjugates, if a plus bi is the real number, then its complex conjugate would be a minus bi. And you can distribute that and check to see that this is true, but I think we see that on the next page. I'm not sure. No, we don't see that on the next page. So let me just rewrite that again. If a plus I is a complex number, then its complex conjugate would be a minus bi. And this is going to come in handy because the thing is, we cannot have, let me show you. When we're dividing, we cannot have an imaginary number or a complex number in the denominator. All right, we cannot have a complex number in the denominator. So it's kind of like what you would do to add or it's kind of like what you would do to add or subtract fractions. We're gonna multiply these. So number 1, we're gonna multiply the top and the bottom, the numerator and the denominator, by the complex conjugate of the denominator. All right. So when multiplying, this is how we divide. It's just we're going to multiply the numerator and the denominator by the complex conjugate of the denominator. So the denominator on number 1 is 5i. The complex conjugate would be negative 5i, because if you think of 0 plus 5i, the complex conjugate would be 0 minus 5i. Well, we don't need the 0, so 5i and negative 5i would be complex conjugates. So we're going to multiply by negative 5i over negative 5i. We're going to multiply both the numerator and the denominator by negative 5i. Since this is the complex conjugate, the bottom is going to become a real number. All right, so this one I have to distribute because there's 2 terms. So it's going to get to both of them. So I have negative 20i and then minus 5i squared in the numerator. And then in the denominator, I have negative 25i squared. All right, well, remember I squared is just negative 1. So this becomes 5. So I have 5 minus 20i in the numerator. And in the denominator, I have 25. All right, well, we do want to write this in its in the form that a complex number should be in, which is a plus bi. So we do want to separate the real and imaginary parts. So we're gonna split the denominator to each of them. We're gonna have 5 over 25 minus 20 over 25i. Alright, I'm pretty much just distributing the denominator to each of these. Alright, I'm going to simplify this, so it's 1 over 5. So the real part is 1 over 5. The imaginary part, so that's 4 over 5, I. So 4 plus I over 5i, if you divide that, you get 1/5 minus 4/5 I. And that would be our quotient. We have a real part and an imaginary part. Alright, let's do number 2. So I need to multiply the numerator and the denominator by the complex conjugate of the denominator, 3 plus 5i. So I'm going to multiply 3 minus 5i, 3 minus 5i, because that's the complex conjugate. It's going to turn the denominator into a real number. Alright, so I'm going to distribute. So I have negative 6i plus 10i squared. Alright, and then I'm going to have to distribute big time here. So the 3 is going to go to both of them. Let me make a little bit more room in my denominator. 3 times 3 is 9. 3 times negative 5i, negative 15i. And then the 5i is going to multiply to both of them, so plus 15i. And then minus 25i squared. Okay, let's try to simplify some of this stuff. Did I get everything correct? Yeah. Alright, so remember I squared is just negative 1, so this becomes negative 10. So in the numerator I've got negative 10 minus 6i. The denominator, these are going to disappear. They cancel each other out. And this is going to become positive 25 because I squared is negative 1. So 9 plus 25, that should be 34. Alright, now let's separate this into, we got to split the denominator to each of these because we want a real part and an imaginary part. So it's negative 10 over 34 minus 6 over 34i. Alright, well these can be simplified a little bit, so we're going to go ahead and simplify these a tad because 2 goes into both of these. So 2 goes into 10 5 times, and 2 goes into 34 17 times. And then same thing for the other one, 2 goes into 6 3 times, and 17 times, and I. Alright, so number 2, negative 2i divided by 3 plus 5i, we get a real part, negative 5 over 17, and then we got an imaginary part, negative 3 over 17i. Alright, this should always be kind of what you are looking for at the end, a real part and an imaginary part. Alright, let's look at number 3. So number 3, 1 minus I is our denominator, so we're going to use the complex conjugate, which is 1 plus I. So on the top, 1 plus I. On the bottom, 1 plus I. Alright, well it looks like I got a little bit of work here, so I'm going to do this over here. Actually, let me get a 2 plus I, 1 minus I. Let me get a screen here. 2 plus I, 1 minus I. Is that correct? Yeah. And I'm multiplying by the complex conjugate, which is 1 plus I. Alright, so I'm going to let me just put some parentheses here so that I can distribute. Alright, so I'm going to distribute on the top. 2 times 1 is 2, 2 times I is 2I. I times 1 is just I, or 1I. And I times I is I squared. Alright, same thing on the bottom. 1 times 1 is 1. 1 times I is I. Negative I times 1 is negative I. And negative I times I is negative I squared. Alright, let me reduce a bit of this. So this I squared becomes negative 1. So I got 2 minus 1, which is 1. These two combined to give me 3i. So my numerator is 1 plus 3i. Denominator, these two cancel out. And then negative I squared is negative 1, so negative negative 1, which is positive 2. Sorry, it's positive 1. Negative negative 1 would be positive 1, so 1 plus 1. So I have 2 in the denominator. Alright, cleaned it up a little bit. Now let's split it into its real and imaginary parts. So 1/2, 1 over 2, and then 3 over 2 is the imaginary part, 3/2. Just need to split the denominator to each of these, 1 over 2, 3 over 2. Alright, so 2 plus I over 1 minus I simplifies to 1/2 plus 3 over 2i. That would be our complex number when we divide these two complex numbers. Alright, so this is our quotient. Alright, so the homework for this part, page 51, 13 through 16, page 52, 13 through 21.